Okay, good morning. Welcome to
FamilyMath929.
FamilyMath929. So we are going to look at some interesting shapes today, and we're going to talk about the angles. And some of the angles are going to involve math your brother is just studying now, so it'll be a little bit advanced, but that's fine. I'd like you to tell me some angles that you see in this shape right now.
Well, we have this square face, all the angles are 90.
Okay.
And on this diagonal here, the angle, these two are 45. These two are 45.
Okay, how did you know that?
Because it just, this cuts the face in half from the two vertices.
Alright, cool. Yeah, try to keep it in the middle here. I think we're okay. Alright, any other angles that you see?
No, we don't really know. I don't really know anything involving this line here. I'm not really sure what that triangle is.
Well, we can figure out what that triangle is. So we'll call the let's call the sides of our cube 2 because some of the shapes we're going to look at later. It's going to be nice to be able to divide by 2.
Yeah.
So just start used to calling the main sides 2. All right. So if the side here is 2, what's the length of that green piece?
That would be 2 root 2.
2 root 2. Right, and how long is the yellow piece?
So that would be 2 root 3.
2 root 3. Okay. So what kind of triangle is this?
It's a 1 root 2 root 3.
Yeah. So we can say something about the triangle. It's just that we don't know those angles.
Mm-hmm.
Okay. But let's talk about some of the angles. One thing we can do is we can use some of the ideas you've been studying in linear algebra to do what?
To find some angles. If we're find that angle, we can probably find that angle.
All right. So which angle should we look at?
Let's look at this angle first.
Okay. Let's look at the angle between the green strut, so the face diagonal, and then the long diagonal of the cube. So I'm going to orient the cube. I'm going to orient it so that this corner here, it's hard to get both of them in the picture. This corner is sort of the origin, and this is the x-axis, the y-axis, and the z-axis. So the green strut, what vector would you use to represent that? Again, we're calling the side lengths 2.
That's 2, 2, and then I guess 0 in the z direction.
2, 2, 0. So it goes over 2 in the x direction, 2 in the y direction, and then 0 in the z direction. What would you say this vector is then?
Well, you're going over 2 this direction, 2 in this direction, and up 2. So 2, 2, 2.
2, 2, 2. And we can use something called the dot product to help us find the angle. If I call this vector A and this vector B, the general formula for the dot product says what in terms of the angle?
The dot product is the product of the magnitudes, or the lengths of the vectors, times the cosine of the angle between them.
Okay. Separately, what's the way you calculate a dot product?
You just multiply the corresponding coordinates, kind of. You multiply first, the second, and the third together, and then add those 3 numbers together.
Okay, so I get 4 plus 4 plus 0, which is 8. The magnitude, what is the length of this vector? Can you tell me what was the length? What was the length of our green diagonal?
It was 2 root 2.
2 root 2. Sorry for the noise in the background. The cat has been going bananas on the couch. And the length of the yellow diagonal was what?
2 root 3.
2 root 3. Times the cosine of the angle. So let's see, 2 times 2. So I get 8 equals 2 times 2 times root 6. So I can cancel the 2's and say 2 equals root 6 cosine theta. So cosine theta is 2 over root 6. So let's see if we can bring in a calculator. Maybe I'll zoom in on it. And we'll see what that angle is. So it's 2 divided by 6. Where's the square root there? Sorry, I'm a long way away through the tripod. And then arc cosine is that one. So it's about 35 degrees.
That's believable at least. You can kind of see that it's less than 45 for sure.
Can you zoom out?
Oh, sorry, thanks. Zoom out.
So
Yeah.
it looks a little less than 45 degrees.
Yeah, it looks like it's less than 45. So 35 degrees. Yeah, so we figured it out. That's cool. All right, let's go to another shape.